Hey YouTube, this is Jim Neve from Jim Neve Woodworks. Today I'm going to talk about a new ESS plugin that came out about 2 months ago. They updated some of the laser commands, and for those of you who are using a laser on your Avid CNC machine, these are kind of important. If you don't know, a lot of the older M-code commands that machines use were like kind of faking out the power levels and turning on and off the laser by going through the S commands or the spindle commands to turn those on and off. Those were not really synchronized very well with the motors. So if you see people cutting images with the laser on a CNC and they have like big burn marks at the beginning or the end of the cuts or the etchings, that's usually because of a problem where the motor stops and then the laser stops, or when the start of it happens, the laser is fired first and it sits there stationary and kind of burns a spot, and then the motor starts to move. So you can't use the spindle commands very well because the spindle wasn't ever designed to be turned on synchronously with the motors on most CNC controllers. And that's true of the ESS or the Ethernet smooth stepper that's in the Avid machines. So over the last probably year or two, Work 9 Tech Design, who designed the smooth stepper and writes the software plugin to go into Mach 4, have been updating the laser commands pretty significantly. So earlier this year they came out with an ESS release that had the M62 and M63 commands, which were nice because they gave you precise on and off commands for the laser, specifically for the laser, that were synchronized with the motor. So you didn't start firing the laser until the exact moment that the motor started to move, and then you could turn off the laser exactly when it stopped, and it took care of those burn marks. But the thing that it left on the table was you couldn't change power settings quickly. The power settings still were not very synchronized. It was very slow speed synchronization with the motor movements. And so in this last release, which is revision 278, they came out with a new command in addition to the previous two. The command is M67, and this is a power setting that is synchronized very closely with the motor. So now you don't really need the M62 and M63 to turn on and off, because when you want to turn it off, you can just simply say M67 with 0 power. And I'll show this some of these codes in the Gcode files that are generated with the Postprocessor. But I'm going to go over some of the advantages of this, and what this really does is it opens up the linear toolpaths, the linear power control toolpaths for pictures, like in Vectric. Vectric lets you scan pictures like these with either dithering, which is not power control, it's kind of dot density control like a newspaper, and it had a linear interpolation of power to try to get the different shades, but because it wasn't timed very well with the motors, it didn't always come out as clear and stuff. So this makes the Gcode a little simpler because you really only need one laser command now in there, and it makes for precise control of power in any kind of laser work you want to do. So I'm going to go over what the Gcode looks like with the previous version and the new version. I'm also going to explain some of the different toolpaths that Vectric has in their laser module, the difference between vector cutting with the laser or vector etching and the rastering options that are in there. There's basically 2 toolpaths, and then the picture toolpath that's for rastering has 2 different modes of rastering. One is just the linear power levels and the other is the dithering. So I'm going to show this with the new software working and do a little bit of comparison on how those work, because a lot of people have asked me, what's the difference between cutting vectors or using the picture toolpaths, and what does dithering do and stuff. So I'll just cover some of those basics as well. I also have a link down in the description section on YouTube that goes to my Google Drive, and there I have the latest Vectric Postprocessor for this. It's one that I modified, and I've tested it with a bunch of different files, so I know it works pretty well. I also have a full PowerPoint instruction for the laser software setup, as well as some of the hardware, you know, the brackets and different things I have in my setup. So it's kind of I just keep a running update of the documentation. So if anybody asks you how did you do this or how to do that, I just have it in that file. So and my screen set. I have a screen set that combines the Avid screen set for the spindle as well as additions that I've put in for laser stuff. And I'm going to do a video later that describes the screen set a lot more, but I do have those 3 files, the screen set, the post processor, and my setup on that drive, and I'll put a link in the description. You can download those and use them for whatever you want, reference or whatever. So hopefully this is helpful. Check out, put questions and comments in the down below, please. If you have any questions, I'm always willing to help. Thanks.
Okay, first let's take a look in Vectric and go over the kinds of laser toolpaths. These are in the extra laser module that you can purchase. Vcarve and Aspire do not come with the laser support by themselves. It's I think it's $50 or something like that, add-on. But what you get with that are these 2 extra toolpaths up here. This first one is laser cut and fill, and then the second one is called laser picture. What these really are is the laser cut and fill is essentially a vector cutting toolpath, and the laser picture is a rastering one. So I'm going to go over the difference between those. So you would use the cut and fill one with something like this. So here I have my logo that I use. You've possibly seen it in my different videos. I used it to test out laser and spindle cutting things. And I use it on my woodworking projects that I sell and stuff as well. This is just a bunch of vectors, this whole thing. So normally to burn this, I would open up this toolpath, and you can see over here, it's very similar to a V-carving toolpath or a profile toolpath or something. You select your vectors, and then you're going to apply a bunch of settings. In this case, the laser power, you can see here, is set to 20%. Your move speed, that's in inches per minute. Number of passes you can cut on or outside. Hatch fill is kind of neat. So something you can select. This is kind of like a pocketing toolpath where you can have the laser go back and forth in a hatch pattern to make an area darker, to highlight it and things like that. So this is going to cut essentially vectors that you've created and do different things with it. Okay, now let's look at the picture toolpath. So in this case, I'm not going to use a set of vectors that I've created. I'm going to start with a picture. So in this case, I've imported a bitmap of a picture of a Australian Shepherd that I have here. And then we would go to the picture toolpath, and you get these options. And now these you're not going to select the vectors on, you're going to select the whole picture, and it's going to calculate essentially it's going to create a bunch of vectors to create this picture, because in the end it has to make burn marks that move along a line of some sort. But in the case of the cut and fill toolpath, you've created the vectors specifically that you want the laser to follow. In this case, you're importing a picture, and there's an algorithm to calculate what the Gcode file, be a series of dots and small lines, needs to be to recreate this picture. And you basically get several options here too. Is it can go in a raster pattern or hatch pattern. So you can control, like, is it going to do vertical or horizontal or some angled lines to create this. Essentially, it's a raster pattern, which means it goes back and forth. Instead of directly following the vectors that you created, it's literally going to just go back and forth and kind of scan and burn these. And I'll show what these look like on the actual CNC. But it's like pretty much any scanning CO2 laser, for example, you've seen making a picture, or similar to, a printer, a dot matrix printer, or even an inkjet. They just go back and forth and create the lines, and after it goes all the way through it, it's, you end up with a picture. So you have two fundamental choices here between how it's going to do this. As I mentioned before, it can do kind of a linear power adjustment. So up here I can say, well, what's my min power and max power? And what the algorithm does then, and says, okay, well, for your min power, which for example might be where there's this white color, right? It's essentially not going to burn anything. That's the lowest power that it would do. And then where it's like you want the darkest black, or in some cases brown, just kind of depends what maturity you're burning. Sometimes it comes out black, or sometimes it comes out, dark brown. That's your max power level. So what the algorithm's going to do then is look at this whole picture and scale the power level anywhere from 2% to 13% in this case, because those are my two values that I've picked, to try and recreate this picture. And it takes a lot of trial and error to figure out what's best, and I'll also show some better ways to figure that out rather than going right into the picture at first. The second mode that this can do this is, instead of scaling that linearly, it can do this dither image, which you just turn on here. And what that does is it's going to use exactly these two power levels. So instead of scaling everything in between and trying to create all the possible shades of this grayscale picture, it's going to use either 2% or 13%. And 2%, essentially, when it's not trying to make any color, it's using the low value, which in the case of dithering, you wouldn't use 2%, you'd use 0%, because you just don't want to burn anything. And then when it's trying to make any shade, it's using 13% in this case, or whatever your max setting is. The reason it does this is because some materials are difficult to burn. Like a very light colored wood, like Baltic birch or something, it's hard sometimes to make a lot of different shades in between, because what happens is the laser at low power levels has difficulty getting the burn started, because it's a very light color, so it tends to reflect a lot of that blue laser light. And then if you're going slower or you're increasing the power, it starts to burn, and all of a sudden the color starts to change from that light color to something darker. Now all of a sudden the power absorption of the material increases significantly, because it becomes a dark color. So it goes rapidly from not burning at all to burning a lot. And so that's why you'll see some materials that you have a hard time creating that whole range of shades, and you end up with kind of, either really dark or really light. And that's what this dither mode is for here, is instead of trying to create the shades by power level, it creates the shades by dot density. So, and this is how kind of the old newspaper print worked, is if you have a darker area, it will make a higher density of dots. So it'll pack them in there, and to your eye it looks darker, versus the lighter areas where maybe a light shade of gray needs to be presented. It will put a few dots, but they're spread out and mixed in with a lot of no burn sites, and so that your eye looks at that and takes that as a lighter shade, because it's basically kind of averaging the pixel density in there to get those shades. And this algorithm works very well for difficult to burn things. And I'll show you the test gradients that I've run. Is from a distance, your eye really looks at sees these as nice gradual shades, and it works very well. So this is one of the options in the toolpath for that. Most of the other settings are the same. You can set your speed and your line spacing, and that's just kind of a thing that's dependent on how big your pixel is. In other words, how big is the dot of the laser you're making. You don't want to have these overlapping, or it kind of smears the look of the image. So there's a lot of things that you can adjust in here and play around with to try to get a good crisp image. And I'm not really going to talk about that so much here, as I want to make the distinction about rastering versus vector burning, and then within the rastering, the dither and the linear power, because that's related to this new software update and why it's important. Okay, now let's take a look at the two toolpaths Gcode files that were generated from that. So on the left, I have the picture of the linear toolpath. So this one has linear power settings, and on the right here is the Gcode file for the same exact picture, and everything's the same except for it's using the dithering. So if we look at the one on the left here first, you'll see these M67 E1 commands. The E1 is the laser analog output, and the Q is the power level. So Q0 is 0 power, and that's where the laser is essentially intentionally being turned off. As I mentioned previously, the power settings that I had for the min and the max here were 2 watts and 13 watts. So you see the Q2 here. So that means it's trying to do a burn at minimum power. And so that's why I know the Q0 here is essentially off, because it's not within that 2 to 13 range. So that's when it's off. And so you see in the beginning, you see a lot of Q2s here, and then there's a burn and then a movement, because the ESS, the smooth stepper, does not ever turn the laser on if there's no movement. And that's the whole point of the M67 command, and as well as the M62 and M63 commands for turning the laser on and off. Is you do not want to have your laser burning if the laser head is not being moved across the material. Otherwise, you're just making a big black burn spot. It's not very controlled. So these, where this says M61E1 Q2, this 2 power setting does not actually happen until this machine feed or machine move happens here. So this moves, and then as soon as it's stopped with that move, the laser will stop burning again. And then now we get another command here. One thing you have to remember with these is they're not always super efficient. You can end up with a lot of kind of redundant Gcode commands in these files. If you look at how Vectric outputs their toolpaths, they output in a certain format that's not converted to actual Gcode yet. That's the whole point of the postprocessor. It takes a generic output from the toolpath and converts it to a specific Gcode for a specific machine. And so they're not the most efficient they could be. You'll see a lot of redundancy here because they have to keep it generic enough so that a postprocessor can be written to create a Gcode file that works for almost any machine. You'll see weird things in here, like the Vectric output will actually try to burn single pixels, for example. That's impossible to do with an Ethernet smooth stepper because you have to actually have some movement. So I've looked in some of these Gcode files, and I'll see where they set the power level on and then turn the laser off in an attempt to burn a single pixel, just a dot without moving a motor. Well, that will actually never create that dot in the first place on an Ethernet smooth stepper because there wasn't a motor movement with it. However, I only have ever seen it do that kind of on the outside fringes where it's trying to kind of create a kind of like a faded effect or something. It doesn't actually seem to impact the quality of the pictures once you get into the actual picture. So that's just, I kind of look at it as kind of a fringe effect that doesn't really matter that much. But anyway, you see, I just wanted to point it out. You'll see redundancies. Like here's a good example of it. You got it off, and then it's setting the power level to 0 where it's turned it off, and then it's set the power level to 2 watt or 2%, and then it has a movement. Well, this first one here is useless, to have it off because there was no motor movement after it. So these actually stack up, and so this second one on line 61 here is the only one that really happens because there's a motor movement right after that. And then you have another one setting it at the same power level again, and then another movement. So you can see all these Q2s in a row here. They're kind of also redundant because the power level is already at Q2 or 2%, and so it's not really necessary to keep having those. But again, that's just kind of an artifact of having this generic code coming out of the Vectric image processor. Going through the post-processor. So anyway, so that's the linear one. If I go way down in the middle of the file, it helps to get more into the center of the image where there's more going on, because at the very beginning and end, you're kind of on the edge effect. So going in here now, we see, Q8s, Q9s, here's Q7. So these are, this is 7% power, this is 8% power, 9% power. So here's a 12% power. So this is almost at the max power setting that I allowed in that toolpath. So you'll see, everything in that range from 2 to 13% in here, and that's trying to create that gradient. So then if we move over here to the right, this is the dithering one. So as I said before, I really should only see 3 different power levels. I'm going to see the Q0 again, where it's exactly 0% power, and that's when the post-processor set it's basically turning the laser off. So it's still using the power command, but that's where it wanted it to be off. And then I'll see the max powers. In this case, I had it set to 10%, not 13%. So I've got actually this one was set to 10% and 0%. So I've got the max power when it's actually trying to burn. I'm going to see these 10s, and then when it's not trying to burn, or when it's off, I'm going to have these zeros. So here you'll see just those 2 discrete values through this whole file. So now if I go down into the middle of the picture, again, I've got 0s and 10s only. So this is dithering. It's a very, very discrete power level on or off. But as we'll see when I show a video of it actually burning a image of gradients, you'll see how the density comes into effect and makes it look there. But you really can't tell, the density at all by looking at Gcode. But so this is a pretty simple laser file. They just, power levels and movements like this X and Y. Z is never being moved on the laser. I took the Z movements all out because you don't want the laser head to retract and come back down like a router does when it has to pull out of the material to move, because that just wastes time. So generally with a with a post processor on lasers, you take your Z movements out of it after the initial move. Okay, this is just a quick kind of reminder of what a vector toolpath looks like. So this is just a quick clip of it burning my logo, and you can see it's just essentially following the lines or the vectors that I've drawn in here. So pretty straightforward. It's similar to a Vcarve or profile toolpath where the router would just follow the lines. So nothing really new here. So this is an example of a rastering toolpath, or the laser picture toolpath as Vectric calls it. And you can see it's just going back and forth and blasting those pixels and sometimes little lines in place to create this picture. And it's just scanning back and forth So there's an algorithm that's converted that image into the dots and lines that it needs to be. So it's not following the toolpath or the vectors that I created, but it's actually one that the algorithm in Vectric created from the image that I uploaded. And you really can't see much of a difference. This happens to be the linear power one, but you really can't tell the difference between that and the dithering one. They kind of both look the same to your eye when they're running. So I'm not going to show the other one, but this happens to be the linear one. But I think the thing that's important to note here is now with the M67 command, the linear power mode here is more capable. Before, the only thing that the ESS can control in the laser accurately, timed well with the motors, was on and off. That works great for dithering because dithering only turns the laser on and off. It doesn't have to change power levels on the fly. But the linear mode requires changing power levels on the fly, and that was previously not timed very well. So the location of when power actually changed versus where the laser was as it was moving was not great. So I think they've updated the ESS to work with this very well now. So you can use both of these modes equally well, and it's more of a trial and error to see which one happens to work best for your particular image and material that you're doing at a given time. So to kind of get an idea of what the linear versus dithering looks like, or the difference between them, one thing to try and look at is a kind of a standard grayscale gradient matrix, which what we have here is something, I just downloaded this bitmap or JPEG, I can't remember which one it was, off the internet. A bunch of people have different versions of these. Basically, this is a scale of a gradient in tenths, from 0% power to 100%, or I should say not power but darkness. And then the bottom one, or the side here, is hundredths. So this is 1, 2, 3 through 10, and then 11 through 19, 11 through 20. And so basically the bottom left one here is the same as the top one on the next row. And what we want to see is no burn. Ideally, if we've got everything adjusted perfectly, we would get a completely white or no burn here at 0 or 1, and then over here this would basically be 100, and we'd get the darkest value we're going to get here. So if we could get everything to be perfect, we would get 100 different markings from the lightest to the darkest here. And this is never going to be perfect because burning things, especially like wood, tends to not be very linear. It'll start out light, like if you're burning this very light colored Baltic birch, it's very light colored, and then as soon as it starts to burn, it turns dark, and all of a sudden the absorption goes way up. So it's very hard to get a gradient, and what you end up with is a more abrupt transition from low power with no burn to, as you get to medium and higher power, all of a sudden it starts burning kind of dramatically. So this is where you see in this linear one here, it's made a pretty drastic transition, and there's not much light to dark. And that's where the dither kind of comes in and makes an attempt to improve that. So in this case, the linear test case here was run between 0 and 15% power on my 15-watt laser at 50 inches per minute. And you can see this kind of is all unburned down in here, and then there's very little distinction between, say, 90 and 100%, and even 80 to 90% here, it almost all looks the same. Whereas if you go over to the dithered one, you can see that it makes a pretty gradual, good gradient in darkness, and you can also see how it's working here. As I said before,
the dither is making more dots, but all the pixels or all the dots are either 0, which is essentially no dot, or the max power. So in this case, I'm also running 0 to 15%, just like over here. But whereas the linear one is putting all the pixels in here, it's packed the same number of pixels into each one of these squares, but it's adjusting the power level of those from 0 to 15%. On the dither, it's either using 0% for no burn or 15% for the dot, and it's changing the density or the number of those dots in there. So you can kind of see when it gets down to very low power levels, there's just, they kind of look like lines, not really dots, but the density is significantly decreased. So the advantage of that is it's much easier to control the burning and get a more consistent density because it's simply changing the density of the pixels. The downside is the resolution isn't that great. You can kind of see, you can start to count the dots when you get down here and you don't have very good resolution. So as you can kind of imagine, if the algorithm isn't very good in placing those pixels in the right spot, you get the benefit of kind of tricking your eye and making it look lighter, but it might not provide good resolution in the image. So it's kind of, this is heavily reliant on the algorithm that creates the image in the first place, whereas this is really relying on the laser to be able to burn the color of the material linearly, which is problematic. So neither one of these are perfect, but sometimes one works better over the other. And you can also see I have the times here. These happen to burn pretty close to the same time. The algorithms really don't change too much here. This one I went from, these were a little bit dark, so I adjusted these to 0 to 10% power instead, and you can see it lightened up the darker areas a little bit and created a little bit of better adjustment down in the lower ranges, especially with the dither. And then I did a linear one here where instead of using 0 for the lowest power, I used 2%. So this one is 2% for the min power, up to 10% for the max. And now you can start to see it started filling the bottom in here, but it also started firing the laser up here in the background and stuff. So you see this kind of dirty, grungy look all the way around. And that's because when it's at the min power, it's actually firing at 2%, which is a little bit too much. So that wasn't very good either. So this is the kind of trial and error you go through every time you want to run a different speed or on a different material. And even if your focus is off a little bit, so your dot size is different, that changes your power density. So from day to day, it's hard to get exactly the same results because a lot of things can affect it. So having one of these gradient matrix Gcode files to run handy to test things out first before you go spend a lot of time burning an image like these that take a long time is good. So with some trial and error, you can kind of figure out what you're looking for, and then now you got the recipe for this particular material. Then you can go try something more detailed on your image itself. So now if we shift up here, this is the same image. That's just a bitmap I got of my daughter's dog, and I ran it first in the linear mode here, but I could tell the power was too low, so I quit in the middle of that. So I'm running 50 inches per minute linear here, but only 10% max power, and I think it was 0% min. So then I went here and moved it up to 20% power. This one's actually pretty good. It's a little bit too dark probably, but once I got that 20%, then I ran the dither algorithm. So this is the same speed, 50 inches per minute, and 10% max power, 0% min. One thing to notice that's kind of interesting here is how much faster the dither took. It was only 35 minutes to run versus the 58 minutes to run. And when I looked at the Gcode files, the linear one was almost twice as big. So there, I'll show you some pictures or some video of the actual laser action. You can see these don't scan like a like a CO2 laser where the head is moving at a constant speed and the laser firing is constant. These are actually more like vector burning, where it each dot or each line is burned, and then the motor stops, the laser's turned off, and it moves over a little bit and then fires again. So this is a very kind of stuttered operation, and so it creates a lot of G-code for that, and it's slow, especially with a big CNC like this. I have, a spindle up here, a lot of weight and everything. This isn't a super fast CNC for this kind of activity, so this isn't super efficient. And one of these days I want to get the rastering feature that's built into the ESS plugin working, because that's a true raster scan and should be a lot faster. But I didn't get it working in time to include with this video, so today I'm just covering the two Vectric, the Vectric picture and the Vectric cut and etch toolpaths. And within the picture toolpath you have the two modes, dither and linear. Then moving over to the right, I just did more versions of linear with higher, adjusting the power just to kind of dial this in. Here was the one we just talked about. Then I increased the power to 2 to 16%, and you can see that's a little bit too dark. And then I changed the power rate, dropped the down to 13%. That's probably a little bit too light. And I didn't keep doing different versions of the dither either. So this is the kind of thing, it's very hard with lasering, and anybody that's very good at it will talk to you and say there are no magic parameters. It's trial and error a lot of times. You'll get good at figuring out what your particular laser will do on a particular material to kind of get a good start. But to really optimize, it takes quite a bit of trial and error, because every material is different. Like I said, the focus is different. There's a lot of other things, even humidity and things like that can affect it, the temperature of the day, how much air pressure you have on your air assist nozzle, all kinds of things. So lots of variables there.
All right, this is an example of it burning the linear mode rastering, and you can kind of see as it goes across the scan, the high power 100% is on the right and 10% is on the left. In this case, 10 or 11%, it's near the top, and you can kind of see how the intensity decreases from the right side to the left side. So the actual power level of the laser is being adjusted on this one, but the grid of dots is pretty consistently high density. Now this is the dither mode one, and you can see very clearly the density of dots, or the amount of marking on the left side versus the right, is significantly less. And you can kind of see as the laser is moving across, the intensity of the beam itself really isn't changing, which it's not, but the number of times, or the amount of dots that get blasted in the low density areas on the left versus the right are significantly lower. So this is not an intensity change, but a density change. Okay, I thought I'd take a quick tour through the postprocessor that I wrote as well. This isn't really a postprocessor training session, but I just wanted to point out some of the features of a laser postprocessor versus the standard machining ones for the router that you've seen. There is a really nice tutorial or manual for postprocessor editing in the Vectric documentation. They actually have a postprocessor manual, and they have a whole section specific to additions for lasers too, so you can read up on it. It's pretty straightforward and not too hard to understand, and once you play around with it a little bit, you can kind of figure out what's going on. So this first section is just a bunch of information that your postprocessor, it's the variables you can declare, like formatting that you want to do, some fixed things that you want to write in every tool, in every Gcode file. So in this case, it's writing the date and the name of the postprocessor and the name of the toolpaths and all that. So just some kind of background documentation. This section here is what is setting up the laser, kind of initializing some of the parameters. And then this section here all the way to the end is kind of the business part of it, where it's taking generic commands from Vectric toolpath outputs to create the Gcode file specific to your machine. So every one of these things here where it says begin and then a command name, initial rapid move, for example, this is the initial rapid move is a command that comes out of the toolpath creation. So when you hit calculate, it creates the object that you're machining, and when you're creating converting from a toolpath, it outputs these commands: rapid move, first feed move. And so that's just a generic thing that says, okay, I gotta go do this thing, and then the command underneath that is what exactly are you going to do for this machine type, right? So this is the Avid machine, which for the most part really applies more to the Ethernet smooth stepper than anything, because that's and Mach 4, because that's the combination that's really digesting these commands in your toolpath. So if we just look at this first one, begin an initial rapid move, it's going to do a G0, which is, as you know, a rapid move, and then it's taking the current position for X, Y, and then forcing a Z0. So this is where I have edited this toolpath not to take the Z from the machine, but I've taken the rest of the Z moves out. That's why I actually have no Z in the file name for this postprocessor, because I don't want the laser to move up and down every time it goes from one vector to another, for example, like a router would do, because it doesn't need to be extracted out of the wood, because you're going to turn it off instead. So this is the only move here that has a Z state move, and that's because this is the very first rapid move of the whole file, and so I'm going to move it to position and drop it down to Z0, and then it's going to stay there for the rest of the time. And so you'll see other rapid moves only having an X and Y, the first feed moves, and then the regular feed moves only have an X and Y. So that's one thing. The rest of these commands, the arcs and circles and stuff, they're all pretty much the same as the regular postprocessor for the for an Avid, for a router or a spindle. But these last three, they're the unique ones for the laser. So you have a jet tool on, which is essentially what will come out of the tool path when it wants to turn the laser on. Has a jet tool off, which obviously is when it wants to turn the laser off. And then it has a jet tool power command here, and that's when it wants to change the power. So all three of these now are using the M67 command, and you can see when there's a jet tool on, it's M67, and it's setting the Q as just the statement for power, and we're taking the present value for power. So whatever the toolpath says the power should be, we're turning the laser on to that power level. Then we have jet tool off. In this case, we're just simply forcing it to 0.0%. So it's not really turning the laser off, it's setting it to zero power, which for all intents and purposes is the same thing, but we use that one command. And then jet tool power is output in the toolpath when it wants to change the power, not necessarily turn it on. Again, this one looks exactly like the jet tool on, because it's just going to set it to the current power. And then these commands are the very last thing that's done. So after your Gcode file has run and you're kind of cleaning up you're doing initial moves. You're moving Z back up to the high position, which is the safe position, and getting your X and Y out to the safe position. So these are the positions here are what you've said is your safe position. That's kind of your starting and your ending position in Vectric. So that's where it's going to take it. Then it's going to, this is a command to set the vector power. This is the old vector power command that's not synchronized to motor movement. But in this case, we use this one just to force the thing to 0 power. M2005 disables the laser. M09 shuts off both of the Avid auxiliary relays. One of them is my air assist, so that's why I always have this on there, because I want my air to turn off at the end. And then these are the end of file commands. So so that's kind of it. These are the three kind of unique commands that came in with laser support in the Vectric software programs. These are the same whether you're using Aspire, Vcarve, or Vcarve Pro. Okay, that's the end of the video. Again, the link is down below for my Google Drive that has the Postprocessor laser screen or laser / spindle screen, and the instruction set PowerPoint files for hooking up the laser and making the software settings. If you have any questions at all, don't hesitate to email me. I also have my email address in the description section, and you can also leave comments or questions in the comment section. I also respond to all of those. So hopefully this was helpful to some of you, and I will have a video coming on the high-speed rastering in ESS when I get that working, and I also will have a video shortly on how to do Mach 4 screen editing and include some of the descriptions and things for those laser features that I added to the screen set that I have on my Google Drive. Thanks. Hope you enjoyed it.